I'm Preetham Nayaka B of Civil Department. These are the problems on design of rectangular combined RC footing. Type 1. Design a slab combined rectangular RC footing problems. Design of combined rectangular RC footing of two columns A and B carrying loads of 500 kN and 700 kN. Column A is 300 mm by 300 mm, column B 400 mm by 400 mm. Center to center spacing column is 3.4 mm apart. Sectional elevation, plan of bottom reinforcement, plan of top reinforcement, CFC combined footing. Given data, column A is 300 into 300, axial load column A, PA is equal to 500 kN, plan B is 400 into 400, axial load of column B is 700 kN. FCK 20 Newton by mm square, FF 415 by N mm square. Step 1. Size of footing or footing slab dimensions. Calculation of loads. Total load of two columns PA plus PB is equal to 500 plus 100 is equal to 1200 kilonewton. Self weight of footing 10 by 100 into 1200 is equals to 120 kilonewton. Area of footing total load by SBC of soil P by SBC is equal to 1320 by 150 is equal to 8.8. Step 2. Progression of footing. The progression of P1 and P2 should be such that CG of footing coincides with CG of column loads. The dimension of x naught of CG of column loads from center of column A is given by P1 by x dash is equals to L by 2. X dash is equal to PA x1 plus PB x2 by PA plus PB. Point column is equals to A, x1 is equals to 0, PA is equals to 500 kilonewton. Similarly, a point column B, x2 is equals to L is equal to 3.4, PB is equals to 700 kilonewton, x dash is equals to 1.9, P1 plus x dash is equals to L by 2, P1 is equals to L by 2 minus x dash is equals to 2.25 minus 2 is equals to 0.25, P1 plus L plus P2 is equals to L, P2 is equals to L minus P1 is equals to 0.85. Calculations of SF. SF must be left A is equals to W into P1, that is 66.6. SF should be right out here. PA minus 66.67 is equals to 433.33. SF just to be right of P. W into P2 is equal to 226.67. SF just to be left of P. 473.33. SF will be 0 at distance from X. A. Calculation of BM. The maximum hogging BM MX will be therefore occur at the section. Sagging BM at A MA is equals to W into 0.25. 0.25 by 2 is equals to 266.68. Sagging BM at B MB is equals to W into 0.85. 96.33. Calculation of depth of the footing. The effective depth D1 for hogging BM is given by D1 is equals to MU 0.138 FCK. D1 is equals to square root of 515.6 into 10 to the power 6, 0.138 into 20 into 200 is equal to 305.62. Punching factored shear force at column B 1.5. Normal shear stress, permissible shear stress. Hence, the depth found from bending compression is adequate. Now assume 60 mm. Step 7. Design of for bending tension in longitudinal direction or design for longitudinal reinforcement. Reinforcement for hogging BM. Step 4. BMD. D is equals to DF is equal to 310. MU is equals to MUX of 515.6 into 10 to the power 6 Newton meter. A is equals to pi by 4 into 16 square 2 not 1.06 mm. Reinforcement for sagging BM. MA is equals to MAA into is equals to 8.33 kilonewton meter. MU is equals to 0.87 FI ASTD 1 minus FI ASTD FCK BD 12.5 into 16 10 to the power 6 0.87 into 415 into 310 AST in the brackets 1 minus 415 AST divided by 20 into 2000 into 310. Minimum area of steel, that is 0.12 by 100 into 2000 into 370 is equals to 888 mm square. MP is equals to MBB 96.33 kilonewton meter or 96.33 into 10 to the power 6 Newton meter. M is equals to MUB 1.5 into 96.33 1.44.5 kilonewton meter. 144.5 into 10 to the power 6 is equal to 0.787 into 415 into 310 EST. 1 minus 405 AST 20 into 2000 into 310 3.74 A square ST minus 925.5 AST plus 144 plus 0.5 into 10 to the power 6 AST is equals to 1352.12 mm square. Provide 12 mm 5 bars at 150 mm C by C at bottom face. AST is equals to 2000 into 113.09 150 1507.86 mm square. Check for one-way shear. Critical section is taken at distance of D1 from column B face. Consider AST provided 904.72 mm square. Percentage of steel is equals to 4.15%. Note down the values. Rho C is equals to 0.28 N by mm square. Permissible shear stress K log is equals to 1 into 0.28 is equal to 0.28 Newton by mm square. Consider B by B dash AST 1507.86 mm square. Percentage of steel 100 AST POV divided by BD F 100 into 1505.86 into 2310 is equal to 0.25%. Provide 8 mm rows 8L vertical stirrups 175 mm C by C in cantilever portion A dash and B portion. Step 9. Design of transverse reinforcement. Column A cantilever projection beyond the face of column A and column B dimension B is equals to 300 mm. So A1 is equal to 850 mm. Width B1 bending strip B is equals to B plus 2DF 300 plus 2 into 310 is equals to 920. Net upward for pressure is equals to 271 plus 73. Maximum BM is equals to MU is equals to 1.5 into 98.16 is equals to 147.24 kilonewton by meter. Area of steel calculation. Since transverse reinforcement will be provided above the longitudinal reinforcement available, mu is equal to 0.87 FIASTD. Spacing 1000 AN 1000 ASTD by AST 1000 into 113.09 1531.84 is equal to 73.82 mm. Provide 12 mm bars and 70 mm C by C for width of 920 mm above longitudinal bars bottom for column B dimension B is equals to 400 mm D is equals to 400 mm A2 is equals to B2 B minus B by 2 2000 minus 400 by 2 800 width B2 of bending strip B2 is equals to B plus 2 DF is equal to 400 plus 2 into 310 is equal to 1020 net upward pressure Q naught PB by B into B2 700 by 2 into 1 by 1.02 343.13. Check for depth of footing. D is equals to square root of mu 0.13 FCKB square root of 164.70 into 10 to the power 6 0.138 into 20 into 1000. AST is equal to 1742.02 mm. Spacing 1000 AST by AST 1113.09 plus 1742.02 say 60 mm. Provide 12 mm row bars and 60 mm C by C for a width of 1020 mm for longitudinal bars. Provide minimum reinforcement for remaining portion. AST MI 89 8 by 2 is equal to 449 mm square. Spacing 1000 AST by AST 1000 into 113.09 divided 449 is equal to 251.80 mm. Provide reinforcement 12 mm row bars into 50 cc for remaining portion and bottom. So provide same reinforcement at top. Step 10 reinforcement details. These are the details. Thank you.